Hi everyone. So in this video I'm going to be going over with you lesson 3.1, so unit 3 lesson 1, properties of triangles. So you'll notice that in this unit we don't have very many of these actual lessons. However, they will likely run a bit longer, and also the material that you're dealing with is more difficult. So the examples that I give you will show you how to apply some of the different techniques that we need to know. But keep in mind that the questions that you get could look different from these questions because it's not about solving a linear system. It's not about doing just some process. You're learning how to apply tools, and applying those tools will be very different depending on the type of problem that you get. So we're not memorizing how to do a certain type of problem. We're trying to understand how to use tools to solve problems. Okay, and so the problems we're going to be looking at in this lesson are going to be classifying triangles, demonstrating their properties. So when we say that you're going to be using tools, the tools again are slope, midpoint, distance, equations of lines, and other tools that you might have learned before. Also, you're going to need key vocabulary related to triangles to understand these problems. So let's just very quickly overview this vocabulary. So we've seen the first word before. The first word is median, and that's a line that connects a vertex or a point on the triangle to the midpoint of the opposite side. So if we're looking at point A, then a median from point A will extend to the opposite side here, and it will specifically connect to the middle of that opposite side. So you can see these two lengths here are the same because this point is in the middle. A triangle will have three medians because it has 3 points, and each median will extend from the point to the opposite side, and it will connect at the midpoint on the opposite side. This brings us to the second word, which is the centroid of a triangle. So that's one of 3 centers of a triangle. There are others which we're not really going to worry about right now. But the centroid is the point O in this diagram here, and the centroid is the point at which all 3 medians of a triangle intersect. So that's where the centroid will be, where all 3 medians intersect, and there will always be one point where all 3 medians intersect. Okay, the altitude of a triangle, if you remember from grade 9 or from some previous class having to solve for the area of a triangle, right? You might remember base times height divided by 2, or half of base times height. Well, another word for the height of a triangle is its altitude. And the way that we understand height is it's a line segment that extends from one of the points of the triangle to the opposite side, and it intersects the opposite side at 90 degrees. Okay, so you'll notice this is different from a median because this point is not in the middle of this side. It's not at the midpoint. It's at the point where the intersection will create a 90-degree angle. So if we put the if we connected the line to the midpoint, you'll notice that the angle produced here would not be 90 degrees. So the median is not the altitude here. It's a different line. And so if you look at this line, you can see that if the bottom was the base, that this line would be the height of the triangle. But what you might or might not have noticed is you can do that from 3 different points on a triangle. Okay, so we have a base here and a height there. So you can solve for the area of the triangle using those 2 pieces as well. So you have 3 altitudes just as you have 3 medians. And they will also intersect at a central point, which we're not going to worry about. The one confusing thing about altitudes, though, is that they don't always fit inside the triangle. So if we look at this case here, we can see that if you go from point B, there's no way you can actually touch the opposite side and create a 90-degree angle. The only way you could do that is to not touch the actual side, but to just come down straight, and then you'd have to further connect this side along here. So it's possible that an altitude could lie outside of a triangle. So just be careful about that. Okay, hopefully these terms here will go quickly. They're just review. We have isosceles triangles, which means they have 2 equal sides. At least their side lengths are equal, we should say. And the angles here will also be equal. So the 2 sides that are the same, they will connect at some angle there. This angle here is the one that's not equal. So it's the other 2 that are equal. We can talk about a scalene triangle, which has sides of 3 different lengths. And will have 3 different angles. And we can talk about equilateral triangles where all 3 sides are the same length. All 3 angles will be the same. And since all angles in a triangle must add up to 180 degrees, If all these angles are the same, then they will be 180 divided by 3, or in other words, 60 degrees. Okay, so that's another thing to remember, right? All angles in a triangle add up to 180 degrees. Okay, so we have to be familiar with this terminology. We have to know about our tools that we've covered in Unit 2, right? How to find slope, how to find midpoint, how to find endpoint, equations of lines, and so forth. So we got all that because this is where it's going to start to get challenging. Okay, but we're going to say relatively challenging because we're going to start off relatively easy here. And we are going to look at proving that some triangle made up of points A, B, and C is isosceles. So I give you the coordinates of all 3 points. I highly recommend drawing the triangle out. Even if you think you don't need to, draw the triangle. You will maybe find that you have to do less work if you notice some patterns when you draw the triangle. Also, it will be easier for you to understand the problem. So please make a sketch of any of these problems. Okay, so we know that isosceles triangles have 2 sides that are the same length. So if we can prove that 2 of the sides of this triangle have the same length, we've proven that the triangle is isosceles. And hopefully we know, if we have points, how to find the length. Right, that's just the distance formula from Unit 2. That's this formula here. So what I'm going to do is I'm going to find the length of all 3 sides, and then we'll just see if 2 of them are the same. So it's the same formula that we've used before. Again, just be careful with your x and your y about what you're subbing in, but as long as you're careful, you should be able to solve this. So if we were looking at A to B, this side, we were looking at points A and points B. So this might be x1, and this might be x2. So we have to do x2 minus x1. I did it reverse here. It doesn't matter the order as long as you're consistent. So if this is x2, this must be y2. If this is x1, this must be y1. So actually, I will do it the same order here. So I called this x2. So this will be y2, this will be x1, this will be y1. So x2 will be -4 minus x1, -1. So that'll be -4 minus -1. Be careful with your negative signs here. Keep track of all of them because, as you're hopefully aware, when you combine these 2 signs, you're going to get a positive. So this is really just the same as -4 plus 1. Okay, -3 minus 3. So that's going to be your y coordinates. I'm not going to go over all this because you can see it here, but we just do some math. Remember, when you square something like this, the negative goes away because this is -3 times -3, so that's a positive number. We get the square root of 45, and why does this say 10? I don't know, but that shouldn't be there. So the distance is the square root of 45. Okay, and we don't know how long, so we could just say square root of 45 units if we like. All right, I'm going to do the same thing for the length between B and C. So again, I would look at the points B and C, and I could make x2, x1, y2, y1. Do the math, and I'll get the square root of 18. So these 2 sides are different, and we probably would have expected that if we drew our triangle in advance. And we're going to expect that if this is isosceles, that this side is probably going to be the same as this one. So AC. So let's get the length of AC, again the same way. We have point A, we have point C. We do x2 minus x1, y2 minus y1, plug that all in, and we get square root of 45 for AC. And so yeah, we can see that this triangle is isosceles because both AB and AC have the same side lengths. Both side lengths are root 45 units. So we do have to make sure that we state our answers. I did notice that a little bit in the first test, that not everybody was writing down what their answers mean. You have to do this in a math question. You can't just assume people will look at this and know what you're saying. So since side A and side AC have the same lengths, since side AB rather and side AC have the same lengths, we can conclude the triangle is isosceles. Okay, so this is a relatively easy example. You'll notice it's a pretty short calculation. Now we're going to get into some longer ones. Okay, so example 2, find the centroid of triangle OPQ made up of points Q, which is at the origin. That's point O, not point Q. So point O, which is at the origin, 0, 0. Point P, which is at 8, -4. And point Q, which is at 4, 4. So we want to find the centroid of this triangle. And if you remember, the centroid is the point where all the medians of the triangle, right, the lines extending from the point to the midpoint on the other side, where all the medians will join. So there's a point in the middle somewhere that's the centroid. We have to find it. Okay, so we know that it's the point where all the medians connect. And so if I was to draw in my medians, it would be here. This might be a little bit confusing. The median from O here is actually just along the axis. So the median is this black line here. Okay, but this is where the centroid will be, and you could probably even maybe already guess what the coordinate is, but we do have to find it, right? If you eyeball something on a graph, sometimes you can get it wrong. So it's a good way to check our work. If we've drawn this out, we should expect an answer that's around 4, 0. And so if it's not close to 4, 0, then we'll know something went wrong. Okay, so we want to find this point where the medians intersect. So what's the strategy going to be? Well, what we can do here is we can find the equation of 2 of the medians. Pick any 2. You don't need to find all 3, because if you just pick 2 lines, you will see that they only intersect at a single point, right? There's only one solution. So pick any 2 medians, find out where they intersect, and that's going to be your centroid. So if I can find the equation of 2 medians, I'm going to choose M1, so this median here. This is not, I'm going to make this a little easier for us to see. So I'm going to choose this one, M1, extending from point P, and I'm going to choose this one, M2, extending from point Q. I'm going to try to find the equations of these medians, and then I'll be able to use a linear system, solve it, and see where they intersect. So how am I going to find the equation? Well, to get the equation of a line, we need 2 points, right? Then you can do m equals y2 minus y1 over x2 minus x1, and then plug in one of the points into y equals mx plus b and your m, and you can get the equation of a line. So we need 2 points. Well, if you're doing a median, you already have 1 point, right? You have the point, the vertex, but we need to find the other point. And the other point is going to be a midpoint. So you can kind of see how the strategy is going to develop here. I've kind of run the question in reverse. I've kind of said, okay, what do I need to find? And then I've kind of gone backwards in how I would find it. So, okay, I need to find the centroid. So to find the centroid, I need the equations of medians, so I can see where they intersect. Okay, to find the equations of the medians, I need 2 points. Okay, one of those points is a midpoint, so I need to find midpoint. Okay, so if we run that backwards, then finding midpoint is the first thing that we do. So let's find the midpoint of OQ, so we can find the point on this median. And let's find the midpoint of OP, so we can find the point on this median. Okay, so midpoint of OP, well, we have our midpoint formula, pretty easy. So we have O, sorry, not OP, OQ. So we have O and we have Q. So O is 0, 0, and Q is, what's Q again? Q is 4, 4. So x1 would be 0, y1, x2 would be 4, x2 is 0, y2 is 4, right? 0, 0, 4, and 4. Okay, so then we get our midpoint is 2, 2, and if you look at the graph, yeah, that looks about right? That's at 2, 2. Let's find the midpoint for OP. So we're going to find the midpoint M2. So O and P, we go and look at our points again. So O is 0, 0, P is 8, -4. So this could be x1 and this could be x2. This could be y1, this could be y2. So we plug that into the formula, and we get 4, -2 as the midpoint for OP. And 4, -2, yeah, that looks about right. So we now have this point, and we now have this point. Okay, so now that we have 2 points, we have this point Q and point M2, we can now find the equation of the red line. And because we have point P and M1, we can find the equation of the purple line. So let's do that. So let's first find the equation M1P, so extending from M1 to P, so this purple median here. Let's get its equation. So we have our 2 points. So our 2 points are 8, -4 at point P, and 2, 2 at the midpoint. So we then use our slope formula, and we calculate that the slope is equal to -1. So the slope of that median is -1, and we can plug -1 into y equals mx plus b. and then choose either one of these 2 points, doesn't matter, to plug in for x and y. So I'm going to choose 2 and 2, right? I'm going to choose 2, 2, just because it's easier to work with. And I get a b value of 4. So the equation of that median that goes from P to the middle of OQ is y equals negative x plus 4. So I have one of the equations that I'm looking for, right? I have the equation of this line right here. So now I need the equation of the red line. And you might notice something a little tricky right away. Well, this line looks vertical. And if you remember, vertical lines have kind of a strange type of equation. We covered how they look. So a vertical line, well, let's actually just find the equation first, and then we can see what that's going to do. So find the equation of M2P, right? So find the equation that extends from M2, sorry, not M2P, M2Q. Whoops. M2Q. Okay, so y2 minus y1, x2 minus x1. So we're going to plug in our points Q and our points from M2. I got that right? Yeah. So you'll notice that when you do this, that you get a denominator of 0 on the bottom. And so you'll get an error if you try and find this. This is telling us that our slope is undefined, and that means that we have a line that is vertical, a line that runs straight up and down. And you can kind of see that looks vertical. All right, so how do you find the equation of a vertical line? Well, remember, it's one of the exceptions, right? A horizontal line has the equation y equals to some number, and a vertical line has the equation x equals to some number. So what is the number that x will be equal to get the equation? And you can look at either point. You can look at the point Q, or you can look at the other point, M2. You'll notice that they have the same x coordinate. So if we look at those 2 points, right, M2Q, the x coordinate is 4, the x coordinate is 4. They're the same. And for this line, the x coordinate will always be 4. So the line is just x equals to 4. Okay, so now we have 2 linear equations. We have one that looks like y equals mx plus b, right? Y equals negative x plus 4. And we also have this weird one, x equals 4. We have 2 linear equations. So we can solve this system of equations, and it's really easy to do by substitution because you already have what x is, right? X is just 4. So let's just take 4 and put it into equation 1. So when we plug it in, we get negative 4 plus 4, so our y value is equal to 0. Okay, so we know what x is already. We don't have to solve for it because we have it. X is 4, and now we know what y is. Y is 0. So the point of intersection of these 2 lines is 4, 0, and that tells us that this is the centroid. And if you wanted to verify that, what you could do is just find the equation of our last median, O, and then to M3, I guess you could call this if you like, and see if that line intersects the other 2 at 4, 0. But that's just to check your work. We've already done enough to solve the problem. Okay, hopefully you're still following along. That one's a little bit longer. The last question is the hardest question. This one's really long. Okay, so we have a triangle, DEF, with the following points, and we want to find the area of this triangle, right? So we need the formula area equals half of base times height, but you'll notice this is not a right angle triangle. So I don't have a base and I don't have a height. A base and a height would look something like this. So this side could maybe be the base, but then the height, I don't have it. So if you draw out what you're trying to find, you can work backwards and construct what you need to do. So, okay, I can choose one of the sides. So I need the length of this side to get my base, and I have a distance formula. So I can find the length of this side very easily, EF. I'll use the 2 endpoints and the distance formula to find the length of that. How do I get the length of this line? Well, this is fairly tricky. You need 2 points. You need this point. But then you also need this point, and this point's going to be kind of hard to get, but we can do it. So let's try and figure out how we can get this point. Well, you can get a point on a line if you know where these 2 lines intersect, right? This point here is the intersection of line EF and this altitude here, right? This green line is, again, if you go with vocabulary, it's called the altitude. So the point of intersection is this point. So if we were to get the equation of EF and the equation of the altitude, we could find the point of intersection by solving a linear system. Okay, so how can I get the equations of these lines? Well, EF is pretty easy. You have 2 points, so you can do what we just did in the previous question, right? M equals y2 minus y1 over x2 minus x1. You can find the equation of this line. But how do I get the equation of this line? And the answer to that is, what do we know about altitudes? Well, we know they're perpendicular, right? They're perpendicular to the line of the triangle, the side of the triangle that they touch. So if I know the slope of EF, then I'll know the slope of the altitude, because if they're perpendicular, then their slopes are negative reciprocals. So I can get the equation of this line if I know its slope and I know a point. I do know a point, and I can get the slope if I have the slope of this line. Since I know 2 points on this line, I can get the slope. That might be a little hard to follow, so let's do this step by step. Okay, so the first thing we're going to do is, we said we need the length of the base. So we're going to find the length of EF using our distance formula. So I just plug in points E and points F, and I get that the distance is equal to the square root of 648. Okay, so I'm not going to work through that calculation. Hopefully you can do that. Now we're going to go through the long, tedious process of getting this point. So, like we said, we need to get the point of intersection here, so we need the equations of both of these lines. So let's get the equation of EF, and then try and get the equation of the altitude. So EF is pretty easy to get the equation. We already have these 2 points, so we sub them into the slope formula. And I get an m value equal to 1. So my slope for EF is equal to 1. If you want, you can even kind of just count, right? You could do a rise over run and just count, and you'll notice that the slope is equal to 1. But you can do the calculation. So we got the slope of EF using the formula. I then take either point E or point F. So I can go back. I have point E. I have point F. I take one of those 2 points and I put it into y equals mx plus b. So I'm going to take 6 and 12. Right? So 12 comma 6. So y is 6 and x is 12. I take my slope that I already calculated and I get, shouldn't say y, this should say b. So b is equal to negative 6, right? If I bring this over, I get a b value equal to negative 6. So then I have the equation of EF. It's y equals x minus 6. And there's a 1 here, right? So if I know that the slope for this line, there's a 1 here, then if the green line is perpendicular, I have to take the 1 and flip it, right? If you take 1, which is just 1 over 1, and you flip it, it's still just 1 over 1, but now it's going to be negative because we have a negative reciprocal. So this line has a slope of negative 1. The green line has a negative 1 slope. Okay, so it's the negative reciprocal. The slope of the altitude, the green line, is negative 1. I also know that this point here is negative 18 comma 12. I'm given that in the question. So now I'm going to do the same thing that I did just here. I'm going to sub in that point, negative 18, 12, and I'm going to sub in the slope of negative 1, and that's going to allow me to find the y-intercept of this line, which it turns out is negative 6. And, well, if you notice something, you've already kind of found this point of intersection because they both intersect at the y-intercept. But maybe you didn't notice that, right? Maybe you just think, okay, there's the equation of the line. Y equals negative x minus 6 for the altitude, and y equals x minus 6 for the side EF. So you have a linear system, you have 2 equations, and we can solve this linear system. So I might just do substitution here because y is already isolated. So I'll just take x minus 6 as my y value and put it down here. So I'm going to replace this y with x minus 6, and then I solve and I get x equals to 0. I sub 0 into one of these 2 equations, it doesn't matter which one. You'll notice that my y value will be negative 6. So 0, negative 6 is the point of intersection. That is what I was looking for. So this long procedure has now given me the point of intersection that I have here. Okay, so now that I have 2 points on my altitude, I can finally get how long the altitude is, because remember, that's what we're trying to find here. Area is equal to half of base times height, and if you've forgotten what we're trying to find, we can kind of forgive you for that. These questions are quite long. Remember, you're trying to find the area of this triangle. So I need the length of this side, and I need the length of this side. Now that I have 2 points, I can get the length of this side. So I'm going to use the distance formula, which is what I always use to find length. I have the point 0, -6. I have point D. I sub them into the formula, and well, what do you know? I get the same number. The distance is equal to the square root of 648. So my base and my height are both square root of 648. Yes, those two numbers are the same. They will not always be the same, so you do have to calculate them. And now I can find my area, half of base times height. So I know my base is root 648. I know my height is also root 648. Remember that when you're multiplying square roots, if you're multiplying a square root by itself, the square root just disappears, right? Think about the square root of 4, right? Square root of 4 is 2. So the square root of 4 times the square root of 4 is 2 times 2, which is just 4. So square root of 4 times square root of 4 is 4. Square root of 648 times square root of 648 is 648. So I get 648 times 1, which is 648, divided by 2. And so the area of this triangle is 324 units squared. So it is units, but we know that they're squared units, so you do have to put the 2 there. And then I have my statement. Okay, so again, that's quite a long problem, and that's why this is taking me longer to go through. And that's why I can only go through a certain number of problems, right? Look how long it's already taken me to do 3 problems. So focus more on being able to use these tools rather than just memorizing different types of problems to solve. Yeah, I'll probably be nice and give you a problem that's very similar to one that you've had on here, but not every problem that I give you will be so similar. Okay, so it's important that you take the tools and you practice and you do all the practice questions so you get used to finding out different things, right? Finding the distance between 2 points, that should just become eventually, when you've had enough practice, automatic. Finding the point of intersection, okay, well then I have to find this and then I have to do that, right? The more you practice it, the better you'll get at mastering the toolkit and the better you'll get at answering these questions. That's it. Thank you.